Hey guys, and welcome back to a new cryptographic Android video. Yes, I will do some security related Android videos because I realized I don't have that on my channel yet. And security is of course very important. And most of these security related videos will in the end deal with data. So in the end, encrypting and decrypting data. That is also what we will start with today. So you will learn how you can actually encrypt a string in Android, how you can decrypt it. You will learn about the Android Keystore system, what that is, and how we can actually use it to safely save our keys. So just a quick demo here what we will actually build, and that is a very simple app where we can enter some kind of string in our text field here, and we can then encrypt that and decrypt that. So for example, hello YouTube, we can say encrypt. You can see that is our encrypted string, of course not readable for us. If we then close our app, we reopen it, and now click decrypt, we will actually decrypt our saved string. So we get hello YouTube again. And I will also later show you that this is really encrypted. So we will save the encrypted content of that string in a separate file where we will then read it from again. So much for demonstration of this app. Before we actually jump into coding, a little bit of theory first, which is important to understand about the Android Keystore system. So when it comes to encryption and decryption, it is very similar as with your house at home. So if you have the key for your door, then you can actually enter it, you can close it, and someone else who also gets that key can actually do the same. So they can also access your house, or they can also lock it. And when it comes to encryption and decryption, it's actually the same. So there we also have such a key, and anybody who gets this key can actually also encrypt and decrypt, or rather just decrypt what you encrypted with that key. And in terms of computers, such a key is in the end just a long series of zeros and ones, or just a long byte array. Now we have a challenge, of course. Where do we actually store such keys? So for example, if you have a password in your app that you want to save, then of course nobody else other than your app should be able to retrieve that password. But if you actually use a key to actually encrypt that password and save that encrypted string, then anybody who gets that key can also decrypt that password. So where do we actually put this key in Android? So in general, you could think about putting that in the internal storage of your app. Internal storage means that is the part of the storage only your specific app can actually access and no other app. However, as soon as your device or your Android phone actually gets rooted, that means that the attacker tries to get access to the whole operating system to basically get root privileges, then they can pretty much access the whole storage of all apps, including all the internal storage, including all shared preferences and all that stuff. So in that case, if you save the key in internal storage, shared preferences or whatever, then an attacker will be able to easily retrieve that if they actually get root access to your device. And as a solution for this problem, there is the so-called Keystore system. And the goal of the Keystore system is actually to prevent an attacker from extracting your keys out of the Android device. So that doesn't mean that the attacker can't use the Keystore system to actually decrypt and encrypt with your keys. That still works if they have root access and basically access to your whole operating system. And you can also not prevent that, because if they have root access, they can do whatever they want. But what they can't do is they can't actually read the key and extract it out of the device to do some other stuff with it. And let's talk about how Android actually accomplishes that it completely prevents an attacker from gaining access to your keys and actually extracting them out of your Android device. And the way this is solved is with a specific hardware, which is usually called like a TEE, so Trusted Execution Environment. And this is basically a separate hardware part that is not part of the Android operating system. So the Android operating system, even if you have root access to that, you don't have that root access to that separate hardware part, which manages the key store. And if, for example, you now have an app, for example, the one we will build here, then we will have such a key that will be stored in this separate hardware part of our Android device. And our app can actually request decrypts and encrypts using the Android operating system. So we can say, hey, we actually want to encrypt this string. This will go to the Android operating system. The Android operating system will then kind of form that request to the Keystore system to actually kind of on the one hand save a key, which will never leave the Keystore system, and on the other hand to actually just encrypt our string with that. So to summarize, a Keystore actually can't prevent an attacker from using our keys. Nothing can really prevent that, but the purpose is to actually prevent an attacker from extracting our keys from the Android system. So in the end, they won't be able to actually use our keys and use them somewhere else outside of our Android device. So I would say we actually get started with coding here, and to actually be able to encrypt and decrypt, I will create a little crypto manager class which will just manage all of our crypto stuff. So crypto manager, create that class here, and inside of here we will write some functions and variables. And we will actually start off with getting an instance of the Keystore, or getting access to the Keystore, by saying private val Keystore is equal to Keystore dot get instance, and we need to pass a type. The type on Android will usually be Android key store. Simply type it exactly like that, and we want to say apply, because we need to load this Keystore. So we can simply say load, and we don't pass any params, so we can simply pass null here. So that way we have a Keystore instance, and if we now want to use that, if we say that, then you can see we get a bunch of functions. We could store something here with this function, we could get a key, we could check if it contains a specific key or alias it's actually called. We can get an entry, that would be whatever we save under a specific alias. And we will now use this here in this class to actually create a key and actually use that to encrypt and decrypt our string. The first thing that's actually needed to be able to encrypt and decrypt is a so-called cipher. So a cipher in the end just kind of tells our app how it should encrypt and decrypt our string. So in the end, we need to specify a crypto algorithm we want to use for encryption. We need to specify some kind of block types and padding, which is just some kind of form how the encryption should actually happen. That is rather cryptographic stuff I won't get into here, but let's actually specify some of these values we want to use here in a companion object. You can say private const val. First one would be the algorithm. We can set that to key properties dot key algorithm AES. That is a common symmetric encryption algorithm to actually just encrypt something using a key. We actually need to add this recurs API M annotation. So this is only available for Android, Marshmallow onwards. We can also take this and put it here, since multiple fields will actually require that. We can then actually duplicate this 4 more times or 3 more times. This one would be the block mode, which will be set to block mode CBC. We want to specify the padding. So again, those are just values that we can specify how the encryption should happen, but if you choose these values, then you're good to go. Here we want to choose padding PKCS7. And the last one will be the so-called transformation, which will basically just combine all these values that we specified here for our crypto algorithm in one string. So we want to say $algorithm / block mode / padding. And we'll just use these values here in our crypto manager class. So as I said, the first thing we want to do is we want to create a cipher, and we need a cipher for encryption and decryption. So let's start with our encrypt cipher, which is equal to cipher.getInstance. And here you can see we need to pass this transformation, which we created down below. And we can then say .apply, and we need to initialize this cipher here with the init command. The up mode is pretty much just saying what we want to do with the cipher. So if it's an encryption or decryption cipher, this one is an encrypt cipher. So we can say cipher.encrypt mode. And the second parameter we need to pass here is the key. How do we get the key? Well, we want to actually create that using a little function. We want to say private function create key. This will return a so-called secret key. And in here we will kind of generate that key and return it in that function. And here we can say return key generator .get instance. Here we need to pass the algorithm, which we specified down below. And we can actually see there is a generate key function, but we want to specify some parameters for this key, for this key generator. So how we want this key to be generated by saying dot apply, and in here we can say init, and we want this init with the params. So we can say, how's it called? Keygen parameter spec dot builder. And here we can now set on the one hand the blog modes, which is our blog mode we specified down below. We need to set the encryption paddings to our padding we specified down below. We want to set user authentication required to false. I think this is actually related to biometric prompts. So if you use a fingerprint in your app and you want to say that this key can only be accessed if the user is actually authenticated, then you can use this and set this to true, but we don't use this here, so we can set it to false. And we can say randomized encryption required, so we actually randomize the encryption, well, the name already says that, and say .build. And then after apply here, we can say .generate key, which you can see returns a secret key. Just like that. So do we just want to take this create key function and put it in here? Well, that would work. But we actually first of all want to check if there is already a key in our key store. So we don't always want to create a new key when we actually want to encrypt something. So what we want to say is we want to have another function, get key, which will also return a secret key. And it will first of all check if there is an existing key by using our Keystore. So Keystore, oops, not that one, Keystore.get entry. And as I said, the alias is basically what is used to ask the key store for our key. So it's basically like a key in shared preferences you can think of. We can say this is our secret key, for example. And the second parameter, the protection parameter, we can set that to null. We don't need that. And we want to cast that as a secret key entry, actually as a nullable secret key entry. And we can then return the existing key .secret key, and if that's null, we simply create a new key. So just what we do here is we check if there is an existing key. If so, we return its secret key, and else we create a new secret key. And I'm just saying we need to pass something here. What is that? We need to pass the alias again, which is just secret again. And the purpose is, like what we want to do with this key is encryption and decryption. So we can say key properties.purpose encrypt or key properties.purpose decrypt. These two purposes we actually have with this key. And then here, instead of create key, we can say get key. And then we already have our encryption cipher. Now we also want that with the decryption cipher to actually also be able to decrypt something. And this will actually be a function. Why will that be a function? Because it needs a parameter. And the parameter is called an IV, or initialization vector. An initialization vector is pretty much just what describes the initial state of our encryption. And that is actually generated when we encrypt something. And we just need to pass the same IV, initialization vector, to the decryption function that was generated here after the encryption. So in the end, that's just, again, a randomized sequence of some bits and bytes. So we can call this get decrypt cipher for IV, and we can pass this IV, which is a byte array, and this will return a cipher again. So we can then return cipher.getInstance, same as above. We want to say apply again and initialize this. This time it's actually cipher decrypt mode, because that's of course what we want to do now. We want to pass get key again. And here at this point, we will actually retrieve the existing key, because that's of course what we need to decrypt what we encrypted before. But when we call or when we use this encrypt cipher for the first time, we will actually create a new key here. But we of course not always want to do that. And now we also need to provide a third parameter, which is an IV parameter spec, to actually provide this IV value we passed above. And that's already it for the get decrypt cipher for IV function. Now that we have our two ciphers, one for encryption and one for decryption, we of course need to use them to actually encrypt something and decrypt something. And those will be the only functions we expose here, so the only public functions which we will specify down below. The first one will be a function encrypt. We will be passing a byte array here, so just the bytes we want to encrypt. And we want an output stream, so where we'll basically write the result to of the encryption. This will be simply an output stream. And we also return a byte array, which will be the encrypted bytes, so we can just show these in a little text. And to actually encrypt our byte array that we passed here now, we can simply say val encrypted bytes is equal to, we use our encrypt cipher dot do final, and that is the function we use to actually use that cipher and do something with it. So here we actually pass our bytes array, which we have as a parameter here. And then here we will actually get another byte array, and that is already the encrypted byte array. Now, we also want to take this encrypted byte array and actually put it in this output stream. Why do we need to do this? Because when we then again want to decrypt what we encrypted here, we actually need this IV value, this initialization vector that was generated here during encryption with our cipher. Because when we then decrypt that, we actually need to pass this byte array here. And a common way to do this is actually to just append this IV in front of the actual encrypted bytes in our output stream. So what I mean with that is we want to say output stream.use, which will just make sure to also automatically close the stream when we're done. And then we can say it.apply. We don't need to apply here. We can also just say it.write to write something to this output stream. We will first of all say encrypt cipher dot IV dot size, which will write the size of our IV vector to this output stream, so we know how much bytes we actually need to read from that when we actually decrypt again. We want to write the actual IV encrypt cipher dot IV, so that is the actual byte array of our IV vector, initialization vector, I mean. And we then want to actually write our encrypted bytes to that. So we can say write encrypted bytes.size again. So we also know how long this byte array is when we actually read this. And we want to write our encrypted bytes. So just the encrypted bytes of our byte array we passed here. And then down here, we can return our encrypted bytes, because that is what we just want to show in our UI. And that's it for our encrypt function. And the next one will be decrypt. Also not too difficult here. This function will actually take an input stream, so which is just the opposite now of our encrypt function. And we will then read this input stream. So basically just what we wrote here, we will now read this and decrypt that and return the result as a byte array again, which you can then also convert back to a string. So in here we can simply return input stream.use again, and in here we can simply read what we just wrote before. So first of all, the IV size, so how long our IV byte array is, we can say input stream, or rather just it.read, which will return an integer, which is just the size of the first entry it actually reads. So it will first of all just read what we wrote here, which is the size. We can then, the next one will actually be the actual initialization vector. So we can now say val IV is a byte array with our IV size. So we just need this to initialize our byte array. And we can then say it.read again, and we can read the result directly into our byte array here, our IV byte array. And that's it for our IV. Next up, we also want to do the same for our encrypted bytes. So we can say val encrypted bytes size is it.read again. And we can then specify a byte array again. So encrypted bytes is equal to a byte array with our encrypted byte size. And we can then say it.read, and we read the result into our encrypted bytes array. And now we of course only have our encrypted bytes, we haven't decrypted them yet. So what we want to do is we want to decrypt them. So we say get decrypt cipher for IV. So this time we use our decrypt cipher, of course. We pass our IV, our initialization vector, which we read above, which again was written to this input stream before here in our encryption function. So at this point, and then we can say .do final. So again, to just perform that operation with that cipher to decrypt in our case. And the input is our encrypted bytes in this case. And that will hopefully successfully decrypt our byte array. So what we can now do is we can go to main activity, and in here we want to just set up a quick UI, which won't look really good, but it will serve our purpose. So in here, let's first of all declare our crypto manager and onCreate. Crypto manager, and we need to add this requires M annotation. Make sure to only launch it, of course, on a device running on M or later. Usually in my code I would add a check for that, but for the sake of simplicity I won't do this here. And in here we will have two states. On the one hand, a message to encrypt. So yeah, just the message we want to encrypt. We can say by remember immutable state of, which is just an empty string by default. Import get value and import this again. And we do the same for the message to decrypt. By remember immutable state of empty string. And then let's build our little UI. We first of all want to have a column. So in the end we just want to have a text field, a text field and two buttons below. That's all we want to have. We want to say a modifier is modifier fill max size, and just add some padding of 32 dp and import dp here. And then in here we want to say we have a text field. The value will be our message to encrypt. And if the value changes, we say message to encrypt is equal to whatever we typed. Let's pass a modifier of modifier fill max width, and let's pass a little placeholder, which is just a text that says encrypt or encrypt string or so. Just like that. We can add a bit of spacer here. Let's say 8dp. And then we want to have a row with two buttons. So we don't need any parameters here, I think. Let's just have a button. If we click this button, let's not do this yet. Let's just first of all build the UI. It will say encrypt, and we can copy this, and let's also add a little bit of spacing with 16dp and paste this button here for decrypting. Okay, so the rest, what we need to do here is to, of course, fill in these on-click listeners so that they actually do something. And as I said, the way I will do this here for this simple tutorial is that we will use a file in which we will actually write our, the encrypted string or the encrypted bytes that we encrypt after we click this button. And then, since that is a file, of course, it will be stored and it will also be able to be retrieved when we relaunch the app. When we then click decrypt, we will read this file and the contents of that into a stream. We will pass this to our crypto manager, and we can then actually get what we wrote to this file before. So first of all, starting with encryption. We first of all want to specify our bytes that we actually want to save in our file. And the bytes will be the contents of our text field, so message to encrypt, encode to byte array. That is how we just convert a string to a byte array. And the next thing is we need to create a file, which is simply a new file. We need to pass a parent and a child. The parent will be our files directory, so just our app's internal storage. And the child will be, let's say we call it secret.txt. If that file does not exist yet, we want to make sure to create this file. So we can say file.createNewFile. And if that file was created, then we can actually also write something to it. So we can say val FOS, which is a file output stream, using our file. And we then say our message to decrypt. Oh, that is actually missing. That we also show a text below, below this row here. Where is that? It's right here. So we just want to show a little text. That is our message to decrypt. So basically just the result of our encryption. So message to decrypt is equal to our crypto manager dot decrypt, and the input stream will be, of course, not decrypt. We want to encrypt something. The bytes that we want to encrypt will be our message to encrypt dot, or actually we converted that above. We can just say bytes, and the output stream will be our file output stream. And now, since that returns a byte array and not a string, it expects us to pass a string, we can say dot decode to string. And then we don't have any issues. So now we can actually encrypt something and save that in a file. Now we also need to reverse that to also read the file and decrypt that. So here in our other button on click listener, we want to say, first of all, getting in a reference to our file again secret txt, and actually in our file directory, and the file is called secret txt. And this time we want to set our message to encrypt to something. So whatever we show in the text field, to just read our file and decrypt that. And that is crypto manager.decrypt this time. And here our input stream is in this case a file input stream passing our file. And again, decoding that to a string. So that should be it for our app. Let's now try this out and launch this. I will launch it on my emulator here. Should also work on your real device. Here we go. That is our app that we just built. And before we actually try this, I want to show you something. And if we go to this device file explorer tab and open this, we can actually see all of our files in our device. So make sure to select the device you actually run your app on. And then you can go to data again. And in here you will find the internal storage of all your apps. You need to find your package name now of the project here. So in my case, it's com.plcoding.androidcrypto, which is this one. And under files, we find our internal storage. So right now this is empty, but if we actually use this now, and let's say we again save something like this will be encrypted, and we then say encrypt, there you go, that is our encrypted string. If we go to our file explorer now and say right click synchronize, then here is our secret.txt file. And if we open this, then here is the encrypted string basically. So you can see that is really encrypted, and yeah, that's working. If we now actually close our app, relaunch that again, and then click decrypt, we can see this will be encrypted. So we successfully decrypted our string again using a key that is saved in the Android Keystore system. So that can't now actually be exposed by an attacker. If you like this video and you don't follow this channel yet, then I would be very happy if you could do that, to simply hit the subscribe button down below. It's free, and we can maybe hit the 100,000 subscribers at the end of this year. That would be amazing. I would be very grateful for that. Thanks for watching. Enjoy your week, and I will see you back in the next video. Bye bye.